Alright, so I guess I'm recording this in 2014 because for some reason all these years it wasn't there and nobody really needed it. That's my feelings, but whatever. But this year Cavill Park asked for it, and it's Thursday afternoon at about 3:52 p.m. Parent-teacher conferences, and not too many parents have showed up, so I thought I'll kind of do this, see if my software is still working, so this is a good test. So 4.3 is about right triangle trig, okay? And what I'm going to be doing is really looking at basics for SOHCAHTOA, okay, which you might already be familiar with. And just to refresh your memory, remember that SOH is equal to, means that sine is equal to opposite over hypotenuse. CA means that cosine is equal to adjacent over hypotenuse, like C for cosine, A for adjacent, H for hypotenuse. And TOA means tangent is equal to opposite over adjacent, T meaning tangent, O meaning opposite, A meaning adjacent. So if you've got a right triangle like this, the angle theta here, and you get the sides A, B, C, then this table really looks like A over C, B over C, A over B. Then CSC, SEC, and cotangent theta are called reciprocal trig functions. Okay, and CSC is 1 over sine, so that just becomes C over A. SEC is 1 over cosine, which is C over B, and cotangent is 1 over tan, so that's B over A. Okay. So this is really a quick review of what you should have done in Algebra 2 at least. Okay. Example, find the 6 trig functions of the given angle. And you have a triangle, so obviously the first thing you need to do is you need to find this side. So you know that A squared is going to be 40 minus 36, which is 4, so A is equal to 2. And then you just fill in this table just like you did in the previous slide. So sine is going to be 6 over 2 root 10. Do not leave a radical downstairs. Reduce fractions. So then this becomes 3 root 10 over 10. Cosine is going to be 2 over 2 root 10. Reduce. No radicals at the bottom. Becomes root 10 over 10. Tangent is opposite over adjacent. So that's 6 over 2 is equal to 3. CSC is the reciprocal of sine, so that becomes, let's see, root 10 goes up at the top, 3 comes downstairs. SEC is the reciprocal of cosine, so root 10, and cotangent is the reciprocal of tangent, so that's 1/3. Okay, straightforward example. Now this is really the favorite topic, okay? Really, really important. The 30, 45, and 60, what I call the magical angles, okay? And so the old school way, and it depends on how you like memorizing these things. I think the old school way, you're taught to memorize a triangle like this, 1, 1, root 2, 45, 45, and this is 90. And then from this triangle, you get sine is equal, sine 45, is equal to, so remember we are talking about 45 degrees now, okay, we are talking about that angle. Sine 45 is going to be opposite, 1 over root 2, which really becomes root 2 over 2, cosine is root 2 over 2, tangent is 1, CSC is root 2, SEC is root 2, and cotangent is 1. Okay, I'm going kind of fast through this because I prefer memorizing these things by what I call the BFF table, okay, the best friend forever table. And I'll show you that in a minute. So let's do the 30, 60, 90 now. Okay, that's this triangle. So do you want to memorize that triangle? It's up to you. Go ahead and do that. To get the trig ratios, sine 30 is going to be 1/2. Okay, opposite over hypotenuse. Cosine is root 3 over 2. Tangent is sine over cosine, so it becomes root 3 over 3. CSC is 2. This is going to be 2 root 3 over 3, and cotangent is 1/2. Okay, that's for 30 degrees. So we're looking at the sides from that angle. And then 60 degrees is going to be, so sine 60 is cosine 30, so this is root 3 over 2. Cosine's half. Tangent 60 is going to be root 3. Did I do this one right? This one doesn't make sense. Cotangent is going to be reciprocal of root 3 over 3, so that's 3 over root 3 times it, so it becomes a root 3. Okay. Sorry, that's not a minus sign. That's, there we go. Okay. CSC is the reciprocal of sine, so that's 2 over root 3. So it becomes 2 root 3 over 3. This becomes a 2. This becomes a root 3 over 3. Okay. So the thing to notice here is that the sine of 30 is cosine of 60. And remember that 30 and 60 are what I call complementary angles. 30 degrees and 60 degrees are complementary angles. Okay. So in general, if you have an angle theta and its complement is 90 minus theta, okay, then the sine of that angle is equal to the cosine of the complement. Okay, that's a general result. Okay, so sine theta equals cosine 90 minus theta. Okay, so my old terms, I used to call this the friends table. Okay, I now want to call it BFF because it looks like that's more current currency. In this year, it'll obviously change in a year. And you really, I use this really heavily, particularly because it's very easy to memorize. Okay, so the first thing to note is that the angles are 0, 30, 45, 60, 90. No big sweat there. And then the radian equivalents are 0, pi over 6, pi over 4, pi over 3, pi over 2. Okay, if you don't know how, if you can't memorize that, that's understandable. But you guys know how to convert degrees to radians. So if it's 30 degrees, you go 30 over 180 times pi, and it gives you pi over 6. Okay, coming from the conversion from degrees to radians. Okay. It doesn't write well at the edge, does it? Okay, let's try one more time. So this is equal to pi over 6. Okay. Right, the reason why this is easy to memorize is just look at these numbers. 0, 1, 2, 3, 4. Oh my God, how easy is that? And you put it all inside a square root. Okay? All of them are inside a square root. It's not like there's only one. And then all of them are under 2. All of them are under 2. Wow, how easy is it to remember that? Instead of remembering that triangle, particularly the 30, 60, 90 triangle, and oh, does root 3 go here or does it go there? Whatever, okay, whatever you prefer you're doing, that's okay. But this is called the BFF table. Why I call it the BFF. Okay? And then notice cosine runs backwards. 4, 3, 2, 1, 0. Duh. Okay? Fairly easy to memorize. I don't need to memorize tangent. Okay? Because tangent is sine over cosine. So all you need to do is take the ratio of consecutive thingies like that and that. Okay? So for example, here, sine of 0 is 0, cosine of 0 is 1, so tangent becomes 0 over 1, which is 0. Okay? So fairly easy to memorize. And that is the last thing I think in this topic. When we go to 4.2, when we go back to 4.2, I'm going to be using this heavily, and I'd really appreciate if you guys can commit this to memory. Again, it's simple because look at the pattern: 0, 1, 2, 3, 4. Okay, 4, 3, 2, 1, 0 backwards. Easy stuff. All right, this is it for 4.3 day 1 at Caval Parek's request.